In this episode, I'm continuing the development of the PC finger shooter mechanic. This one can be split up into three main chapters: the overhaul, feature A, and feature B. The overhaul, however, was quite substantial and cost most of the development time, so this will also be split up with its own chapters. Let's begin with the overhaul. First things first, I had a few people playtest the latest build. From how they played, I concluded that people really wanted to shoot more than just a 4-finger limit per hand. Initially, there was the over-engineered concept of shooting finger mimics, fake duplicates of the fingers. This had some potential, but I opted to go for an easier and quicker solution, which is to simply return your fingers when you desire to shoot more. There is also the option to have the fingers regrow instead of return. It's not being used yet, but it could be useful in the future. I was also personally annoyed at the design flaw that when the player claps, you have to wait for the complete centroid expulsion routine to end, before you could continue shooting. I essentially forced a cooldown period on the player's actions due to a lack of quality in my code. This flaw was fixed by simply allowing there to be more than one centroid. I say simply, but this introduced quite a bit of refactoring. Next was making the centroid magnetism a more satisfying feature. The timings and the speeds of the pull of the objects were the first things that were played with, and some results were promising. The next change was something that could null the previous one, but it is warranted at least a try. That would be a curved pull of the objects to the centroid, courtesy of a YouTube comment that gave this idea. Then me, being the over-engineering dum-dum that I am, instantly starts thinking about how to have custom parameters and restrictions that influence this curve, because a curve can take many different shapes, and knowing which ones I want is pretty crucial for the game feel. Now I'm not so patient or talented enough to tell an object to find the perfect curve to the target, no matter the scenario, so I decided on a very simple ruling. A charged object will have one desired curve direction that it wants to take. If this desired curve intersects with terrain, I proceed to check for a curve that is rotated 90 degrees from the previous one. This check is made a maximum of 4 times, after which the object states that it could not find a path. In other words, when I clap, such objects will not attempt to move to the target, as terrain seems to be blocking them quite well. How I check whether a curve intersects with terrain is also done with a mere 2 raycasts. A first raycast from A, the object, to B, the furthest point the curve has from the line that represents the straight direction. A second raycast from B to the centroid. If either gives a hit with the terrain, then that curve is a no-go. Obviously, this whole process is a pretty simple and inaccurate way of saying an object cannot travel a path. The 2 raycasts do not nearly represent the curve's route, and I also do not account for the object's size. I do deem it enough for now, as its simplicity is useful. After all, this is logic that needs to be calculated for every single charged object. I was afraid this could cause a stutter on the frame it wants to calculate all the paths, so I proceeded to have charged objects calculate their paths over a small period of time upon their creation. When I clap now, hopefully most objects will have found their desired path, and any that have not yet tried will be forced to do it in the frame of the clap. Also, remember that comment I made regarding using non-self-made assets and making sure you're wary of possible performance costs? Well, you see, the shader I was using to color my charge objects was in fact a huge bottleneck. It was actually the reason that for a while a stutter was present at the start of the expulsion. A funny thing, however, is that I literally wrote it next to the code responsible that it was a heavy performance cost, way back when I first implemented the shader. Guess I forgot. As a workaround, charge objects will be visualized differently so that the game runs more smoothly. After the previous update, I also noticed that I could potentially shoot an object that is being pulled and cause the inverse discharge interaction. This resulted in some unwanted behavior. Thinking this through, if I'm planning on creating additional features, more of these situations will undoubtedly happen. If I want more features, then I first need a system that can deal with such cases. My methodology is effectively giving each charge object a job. Currently, if one object has a job, it will refuse to do any other behavior than said job. Let's take the centroid pulling and exploding mechanic. Charge objects mainly do two things here. The centroid pull, being pulled towards a target. The centroid expulsion, exploding away from the centroid. Now the moment I clap, all charge objects without a job will be assigned the job centroid pull. The moment we need the centroid to explode, all the objects with this job that are present in the centroid will get the new job centroid expulsion. This way I can easily create new features, aka new jobs, and possibly tinker around with the interactions in case I do want some of them to mesh. That stupid jittery movement on the fucking hands, oh god, end me. When I made the first devlog, I pretty much only playtested with a controller. I personally much prefer playing with one rather than a keyboard and mouse. This caused me to not take notice of the incredibly stuttery movement of the hands, which was far more prevalent with the keyboard and mouse controls. At first, I thought it'd be best to just scratch my method with joints and to just use code in the update to move and rotate the hands transforms. However, I was peeved. Surely it had to be possible with joints and rigid bodies rather than hard coding the transform component. After many iterations of how the player and hands are built up, I eventually found a satisfying working solution. Now onto the features. Feature A, grabbing and throwing. Honestly, I don't know what to say really. I was missing the aspect of player freedom, which was central in the prototype, so I decided to implement a grabbing and throwing feature. This would give the player the ability to grab charge objects from a distance and throw them wherever they please. It was quite easy to create thanks to their job system created previously. With the inclusion of some sounds and particles, it turned out to be a fine addition. Feature B, flicking the thumb. Up until this moment, I had still not implemented a proper way for the thumb to do something. Well, other than doing that little animation when returning missing fingers. I thought of a way for the thumb to do something more significant. An action that causes the thumb to be ejected upwards from the hand, after which the player has to properly time their flick to send it propelling forward. I figured needing the correct timing to flick would differentiate this feature a bit from simply shooting. A little detail I added was to have the hand slightly shift position when preparing to eject or flick a thumb. This would make the action take place more in the center of the screen. Having the thumb not stutter in its movement was a similar problem as the hands, but after having fixed this once before, doing it again was not as strenuous. What the thumb projectile actually does can easily be changed, but for now it's been made to be a very fast explosive that reacts to immovable terrain, pushing anything else aside. After creating its behavior, I added some particles and sounds for when the flick happens, as well as a change in its effect in case the player misses. Finally, due to the increase of features, there will now be a billboard with instructions on how to play within the game world itself, rather than overflooding the UI. And here's where I'll conclude this part of the finger shooter. I'll likely leave it on the back burner and begin a different project. A project for which, above all, a game loop will be designed, with the intent to realize it all into an actual, available game. Thanks for watching, and I hope to see you next time.